Hey everybody, welcome back to Intermediate Microtheory. Today we're going to go over some practice problems that are in the participation activity and just do a little bit of review of consumer choice. So we've looked at indifference curves, utility maximization, and budget constraints, and today we're going to solve a couple of problems. So the first problem is actually in the homework and in the book, and it looks at the budget for consumers consuming two goods, gasoline and everything else. So hopefully this is a nice opportunity to practice with something that you'll see a couple of times and you'll be totally ready for when it comes up in the homework. So we want to, first of all, graph the budget constraint for a consumer consuming two goods, gasoline and everything else. And this is going to be one of those problems that we kind of deal with qualitatively rather than quantitatively, rather than with a lot of mathematics. So I'm just going to kind of guess on this stuff. So I've got some quantity of gasoline, and then consumers will consume everything else. Sometimes in word problems, they'll call that a composite good, and they'll just say, they consume two goods, X and gasoline. And gasoline is gasoline, and X is the composite good of everything else. And I'm just going to go and guess on some budget constraint, and this is just our initial condition, and then we'll move things around based off of that. So I consume some amount of gasoline, some amount of everything else. That's our initial point. Part B says, what happens to the budget line if the government imposes a $1 tax on gasoline? Graph the effect and label it L1. So I'm going to call my first budget constraint, that's L2. So I'm going to call my first budget constraint L1. And then if the government imposes a tax on gasoline, that's equivalent to raising the cost of gasoline, not everything else. So remember, if we have an income change, that'll shift the budget constraint out. If we change the price of one good, we're going to see a rotation. So nothing happened to everything else, but gas has gotten relatively more expensive. Consumers are going to consume less of it. So we're going to see the budget constraint shift in by about $1, right? And it's going to shift that way because the consumer's budget hasn't changed, but the relative affordability of gasoline and the relative utility relative to price has changed, and that's going to change that slope. So that's part B. Easy peasy, right? Part C says, how would the effect be different if the tax only applied to consumption of more than 10 gallons of gasoline? Graph that change and call it L3. Oh, that's supposed to be L2. There we go. So that's a little bit trickier. And so to do that problem, I'm going to have to see where 10 gallons of gasoline are. So I'm just going to make it here so it's simple for me. I'm going to call that 10 gallons of gasoline. Again, this is a qualitative problem. There's not a lot you can do to really make it mathematical because I'm not giving you a lot of data. So you want to just sort of feel out how the graph would be. And so the thing is, if the tax only applies after a certain consumption point, that means that the budget constraint will remain unchanged until that point and then rotate in. So we're going to have a third budget constraint that follows the first one up until that 10-gallon consumption point and then rotates in like that. And we'll call that L3. So far, so good. Pretty simple, pretty straightforward, hopefully. The next problem says that Andy purchases two goods, apples and kumquats, and we've got income and marginal utility here. So this problem we are going to solve as well as graph. So Andy purchases apples and kumquats. Andy has an income Y equal to $40. We have the price of apples is $2 per pound and kumquats are $4 per pound. And we also have Andy's utility function. His utility function, which is a function of apples and kumquats, is 3a plus 5k. Cool? So given this information, we want to see what is the utility maximizing bundle of apple and kumquats that Andy should buy. And to do this, we have to go back and remember what we learned in lecture. Oh my gosh, right? So you want to remember that we find that utility maximizing point when the budget line is tangent to the indifference curve, right? When the budget line is equal to the indifference curve. And that happens when the slope of the budget line is equal to the slope of the indifference curve. Remember, the slope of the indifference curve is the marginal rate of substitution. The slope of the budget constraint is the marginal rate of transformation. So remember, we had that part where we said MRS is equal to MRT. That's our utility maximizing space. We also looked at it another way, right? We said that MRS is equal to MRT is the same as saying the marginal utilities, the ratio of the marginal utilities is equal to the ratio of the prices, right? So we have the marginal utility of apples relative to the marginal utility of kumquats is equal to the ratio of the prices of apples to the price of kumquats, which is the slope of the marginal rate of transformation, right? So if you don't really 100% remember that, go back and check. And remember where we derived that the marginal rate of substitution is that slope of the marginal utility curve, and it's that relationship between those marginal utilities. And then the slope of the budget constraint is based on the ratio of the prices, right? It's the exchange that the consumer makes as they move along the budget line. Same as this is the marginal rate of substitution of apples for kumquats. So when we set them equal to each other, we get that utility maximizing point. And we can do that by just saying that we can look at the marginal utility of apples divided by the price of apples and set that equal to the marginal utility of kumquats divided by the price of kumquats. That's how we're going to solve this problem. That's how you'll solve a lot of these algebraic problems. Okay? So, given that we have all of that, we can find the marginal utility of apples relative to the marginal utility of kumquats. And we have it built in right here. If every time Andy consumes another apple, he gets 3 additional units of utility, we can say that the marginal utility of apples is equal to 3, and the marginal utility of kumquats is equal to 5. Right? Make sense? So far, so good? So, we can come down here and let's calculate this. So, the marginal utility of apples relative to the price of apples is going to be 3 divided by 2. The marginal utility of kumquats divided by the price of kumquats is 5 divided by 4. So there's 2 things going on here. First of all, Andy gets way more utility from kumquats than he does from apples. But kumquats are also more expensive than apples. So what we're finding here is how much utility on the margin Andy gets for each dollar he spends. So how much utility comes from spending $1 on apples or $1 on kumquats. And that's what this ratio is showing us. And so it turns out that the marginal utility of $1 spent on apples is 1.5, and the marginal utility of $1 spent on kumquats is 1.2. This tells us that Andy would be better off spending all of his money on apples, even though he enjoys kumquats. They're so expensive. If we wanted to go in, so what the answer is, what's the solution? The answer is that the utility maximizing bundle is going to be $40 spent on those $2 apples, which is going to be 20 pounds of apples. That's his utility maximizing bundle. And we can graph that. Let's graph that utility curve and the indifference curve and that optimization point. And it's going to be one of those corner solutions that we talked about at the end of class on Wednesday. So we have Andy can choose to either consume kumquats or apples. And if Andy spends all $40 on apples, he can consume 20 pounds of apples. And if Andy spends all $40 on those kumquats that are $4 each, he can consume 10 pounds of kumquats. So that gives us an indifference curve, right? Now we want, sorry, not an indifference curve, a budget constraint. That's Andy's budget constraint. All the money that he can spend, all $40, can be spent on either apples or kumquats. Now we want to go ahead, give that a little bit more space, and graph the indifference curve. We already know that the optimal consumption point is going to be right here. And so we can draw an indifference curve like that. That shows that optimal consumption point. That doesn't quite show up. Let's try this one. There we go. And so that's going to be the optimal bundle. And we can label it E for no good reason. That's where Andy is going to maximize utility and be the best off. And we can see that too, because if we imagine if that is the optimal indifference curve, no higher indifference curve is possible and no lower indifference curve is going to maximize utility. We have a corner solution rather than an interior solution, and we've maximized Andy's utility subject to his preferences and his budget constraint. So I know that was a little bit quick. We can try to go over some other problems. If you go ahead and comment in Canvas in the discussion board, let me know what homework problems you have questions about, and we can talk those out. Otherwise, have a great rest of the day, and I'll see you next time.